In this video, I'm going to show you how to get the derivative of different functions. But before we go to different types of functions, I will be showing you the basic rules in differentiation. The first of the rules will be the derivative of a constant function. So for example, if I want to get the derivative of f of x equals 3, how do we get the derivative of f of x? So the rule for this is the derivative of a function when the function is a constant. So you're deriving, say, f of x is equal to c, where c is a constant. The derivative of the function, so of the c, is equal to 0. So whenever the function is equal to a number, the derivative is basically 0. So for this function f of x is equal to 3, the derivative, which can be written as df dx, or you can use f prime of x, the derivative of this function is basically 0. If I make it 100, then the derivative is also 0. If I'll make it 1 million, then the derivative is equal to 0. Okay, so that's one of the basic rules in differentiating functions. The second rule that you need to know is what we call the power rule. So if the function is given in the form of x to the n, the derivative of the function, with respect to x, or simply f prime of x, is given by n x to the n minus 1. So as you can see, in simple terms, it's like moving this n down here, and then you have x raised to n subtracted by 1. So if the function is equal to, say, x cubed, the derivative will be 3. So look at how the exponent was moved before the x, and then we have 3 minus 1, which is basically 3x to the 2. So note that I'm saying it in simple terms, so it's like as if we're moving the 3, but there's a proof to that. There's a long proof on how we can get this formula, but just for you to easily understand it, so whenever you have an exponent of x, then this exponent will just be written before the x, and then you subtract 1 from the exponent. So another example would be if I have f of x, say x to the 10, then the derivative of f is basically 10x to the 9. 9 is 10 minus 1. Okay, the next rule is what we call the constant. So we have the constant multiple rule. So let's say we have a function equal to 2x to the 3. So there's a constant being multiplied to an x raised to a number. So the rule for this type of function is that the derivative of f with respect to x, which is basically f prime of x, will be equal to, so let's make it in general. If the function is, say, there's a number c and x to the n, okay, the derivative will be, it's the constant, and then the derivative of x to the n with respect to x. So in simple words, if f of x is equal to 5x to the 6, the derivative of f of x will be 5, and then differentiate x to the 6 over or with respect to x. So that simply means 5, the derivative of x to the 6 is 6 times x to the 6 minus 1, which is 5. This is just equal to 30x to the 5. Now if you look at it, the constant multiple rule is simply, or it's the same as if you're multiplying the exponent with the constant. So 6 times 5 is equal to 30, and you have x to the 5. So the next time you see a function, for example, you have 4x cubed, then the derivative of this will be 12, that's 3 times 4, then x, remember to subtract 1 from the exponent, so this will be 2. Okay? The next rule is what we call the sum, or it can be the difference rule. For example, if my function is written as, say, 5x to the 4 minus 10x squared plus 3x plus 2, then the derivative of the function is simply the derivative of the sum and the difference of the functions, or the terms rather. So, for example, 5x to the 4, we know the derivative is 20x cubed, and then just proceed differentiating the other terms. So, minus 10x squared, the derivative is 20, that's 2 times 10, so you have 20x to the 1, so to the 1 means x to the 1 is the same as x, and then derivative of 3x is the constant times the derivative of x. Now note that x is the same as x to the 1, so this is equal to x. So when you get the derivative of x by the power rule, so let's say the function is x to the 1, so f prime of x is equal to bring down the 1, and then you have x 1 minus 1, which is 0. X raised to 0 is equal to 1, so 1 times 1 equals 1. So this is just 3 times 1. Now if you look at it, the derivative of a function, whenever the function is in the form of a number with the x, the derivative is always that number. So just to explain that further, if f of x is equal to 10x, then f prime of x is equal to 10. If f of x is equal to 6x, then f prime of x is equal to 6. So if I have 3x, so that is simply 3. Now, so I'm writing one here just to explain the idea on how we can get the value 3. But the next time you see 3x, the derivative is basically 3. Now, the last number, or the last term, is a constant. Remember that in a constant, the derivative is equal to 0. So this is plus 0. So simplifying, you have 20x cubed minus 20x plus 3, because 3 plus 0 is basically 3. So this is f prime of x. Okay, so this time, let's find the derivative faster. So let's say I have 10x to the 3 minus, say, 2x squared plus 5x minus 9. The derivative is simply 30x squared, that's 3 times 10, 30, then x, 3 minus 1 is 2, minus 4x, and then the constant x, so from this rule, the derivative is simply 5. The constant will become 0. So that's how you get the derivative whenever you have a sum or difference of terms. Okay, so you can simply put it the derivative of a polynomial function.